All right, guys, Mr. Antonucci here, and I have with us today a definite integral. It says evaluate the definite integral from 1 to 2 of x squared minus 1 dx. Now, basically what a definite integral is calculating, it's calculating the area under the curve, and I should say the signed area under the curve between the curve and the x-axis. And what I'd like to do is show you a picture of what this looks like. So if we go to DESMOS here and we type in the function f of x equals x squared minus 1, and then I'm going to put the limits x equals 1, x equals 2 in here. And so this is the graph of x squared minus 1 in purple. And then I just put the limits on here as vertical lines just to show you the region that we're going to capture. And what we're actually doing with the definite integral is we are calculating the area of this little region right here. Now, one of the things you can do to check the reasonableness of your answer is to draw a shape that closely resembles the area of that region. For example, if I put a triangle on here in black, okay, the area of that triangle is 1/2 the base, which is 1 unit wide, times the height, and the height is roughly right about here, which is about 3 units high. So 3, and 1/2, 1 times 3 gives us 3/2, which is 1.5. So when I calculate this, I know my answer should be close to 1.5. Okay, it's probably going to be a little bit less than 1.5, but I just know that's a ballpark. My answer shouldn't be negative because none of the region is below the x-axis. All the region is above the x-axis, and it's kind of inside that triangular shape. So I know it should be 1.5. So if I get a negative, if I get 0, if I get something much larger than 1.5, did something wrong there. Okay, so first thing we want to do is take the antiderivative. Now, according to the power rule for antiderivatives, you add 1 to the exponent and multiply by the reciprocal of the new exponent. And then the antiderivative of the constant is that constant times x. Okay, and you can always check your antiderivative by differentiating it, and you should get what you started with. And then we put a bracket here with the 1 and 2, just to notate that we're going to plug in 2 and then plug in 1 and subtract those. Notice also that the definite integral symbol in the dx came off because I performed the operation that they were implying. They were implying take the antiderivative. I did it. It's very similar to when you take the square root of 16 and you write 4 and the square root symbol goes away because you performed that operation that the square root symbol implied. Okay, so now what we're going to do is evaluate this at 2. And subtract that from the function evaluated at 1. Now, the use of parentheses here is very important because I'm subtracting a quantity right here. Oh, that should be an exponent of 3. Okay, I'm subtracting that whole quantity. So you'll want to put that whole quantity in parentheses. Okay. 2 cubed is 8, so that's 8/3 minus 2 minus 1/3 minus 1. So 8/3 minus 2, 2 is like 6/3. So 8/3 minus 2 is 8/3 minus 6/3, which is 2/3. Minus, now 1/3 minus 1, 1 is like 3/3. So that's minus 2/3. So 1/3 minus 3/3 gives us negative 2/3. 2/3 minus negative 2/3 is 4/3. Now, if you know anything about thirds, that's going to be 1.333 repeating. And that's very close to the answer that we conjectured at the beginning, that we should get about 1.5 as our answer. So I hope that was helpful to you. Make sure you subscribe and hit the bell for notifications. And if you have a problem that you would like me to go over, whether it's calculus, trig, algebra, pre-calculus, any of those topics, put it in the comments below, and maybe I'll be able to make a video about it. Take care.